positive cash flow 4, 5, 4 in the respective 3 years. Okay? Okay, 9,005. Going to receive this cash inflow. Find out the IRR. This is the IRR. When NPV equals to 0. Okay. Right here. In the subject max here, give you carry it on and then try the different rates. In the subject max, try the 10%, you try the 20%. Okay? Try 20% have one NPV which is negative 380. Okay, and use the 2 rate fine. The IRR is 17.5. Your company total rate is 7%. So the project is 70%, so it's higher than the 7%, so they're going to accept. Okay. From here, you will know what the subject is talking about. You have to see the detail working. Go back to the sum formula. This risk-free rate of 7%. What is the risk-free rate? What are the 2 investments are risk-free? One is the government bond, the other is saving. Save the money in the bank. Okay? So the saving rate and the loan interest rate are quite similar, but normally slightly higher than the saving rate. So write down this risk-free rate of 7% ends up to be the hurdle rate. This ends up to be the hurdle rate. That means that the company new project should be more than 7%, otherwise they are not going to do the project. Okay. So the detail working for this case, is given in the following slide. Okay. Get a little bit more about the IRR first. The method to find the IRR, now your subject guide gives you this formula already, and this is the interpolation method. And we must have one NPV positive, one negative NPV, one positive NPV. This way to find the IRR is just an approximation. It's an approximate answer. It's not exactly very, very accurate, but this is the best way to come already. And in your subject right here, the method, the formula that they use, here is also use the positive, not the negative one. Use one low discount rate, use one high discount rate, and find their respective NPV. And get the absolute form, absolute value, irregardless of the positive or negative, when you plug into this interpolation method. Okay? Detail of this, I set it down. Here it doesn't tell you what are the steps. Detail of it, I set it down in your subject in your handout there already. This is the step that I show you the key concept before. Step to solve, there are step 1 for energy rate. 1 for 1 R. And find the IRR for the small and big. But it has to be one positive, one negative. Step 3, plug into the interpolation formula. Alright. In the exam, you don't have this. You have to know the step rate. And remember this formula. Or have to remember this formula. Okay. So here I show a very simple working. Try a small r, let's say 10%, and find the NPV for the smaller r. Try the bigger r, let's say 20%, and find the NPV for this bigger r. And it must be one positive, one negative. Okay, class. Let's say you have found the first r. Use the first r to find the NPV. The answer is positive. So the next one, you know that you must get something negative. So this rate, it must be higher or lower? Definitely higher. I repeat, if you want to get a negative NPV, the rate must be high. If you want to get a positive NPV, the rate must be small. Okay? But please don't try 4% if you want 5%. Okay? Don't try one, oh, this one 10% and this one 4%. You won't find the answer. Okay? But you also don't try, okay, say that too close already. So here try 10% and this one try 50%. Don't be the extreme, okay? So it's about 10% gets this. Normally we try 10, 20 or 10, 30. Good enough. Okay, so this one, this should be alpha omega. Okay, now let's go and use this one. Just come to illustrate to you what is IRR. We want to project, find the NPV, is the try 10%. This is the one for our, just now the example. This one, 9,005, 4,000, this one, example. Just now I said that you will go to the video working. 454. See the next slide for detail working. The detail working after the formula is here. 454. You get 9,005 to buy the machine in the 3 years you're going to get this. Try one low IRR, low rate, find the positive NPV. Try a bigger rate, find the negative NPV. Okay? Use this for information. Plug into this formula. Do you have the working gas? Does it show the working gas? Okay. Let's not do it. Okay, I will show the complete one. Then you go get the back. Okay, you have this on your page 15. Okay, this on page 15. Smaller r, positive. Bigger r, negative. Use this for information. Plug it into this formula. Okay, and must remember.
Sorry, I'm having class. Yeah, I'm at block B.
Okay. Alright. Front is the smaller r. So put 10%. Second element here is the big R minus the small r. The big R is 20%. Minus the 10%. Above is the NPV for the smaller one. For the smaller r. 127. Below, combining these two. But don't take the sign. Okay, so it's a 1273.66 plus 380. You do what minus r? Just get the value, ignore the sign, get the absolute value. Have the absolute value of this. Okay, solve this and you get 17.7. Can do all? Okay, get this 17.7 already, then you need to draw this NPV diagram. Okay, 0 here. So you use the different rates. And the different NPV. So 10, 15, 17.5, 20. Okay? And when the rate is 10, NPV is 127. So here we go. Let's say this is 50, 100, 150. Let's say 120 is here. And at the rate of 20, NPV is negative 3. You see, if we only have these 2 points and want to draw a line, and the line where it cuts off, do you think we'll get a 17.5 exactly? Will not get a very accurate answer. Okay? So that's why I always say that you work out this first and just show the graph. And this graph you purposely put 17.7. To show the examiner this is the outcome. That's all. MDB, you should be able to do so it's a simple working. Okay, you have the homework for you to do. Activity 7.3. Activity 7.3, this is the homework on page 16 of your okay, this is the homework. Okay, and you can take a picture if you want to double check answer. Of course, the answer is always available at the back of your subject guide. The worksheet of the activity 7 is on the following slide, still on the page 16. But if you want to see the detail working, here is the detail working. Answer is given in your handout there already. Okay, this is the activity 7.3. Okay, let's go to the past year question. This past year question is available on your review exercise 7, page 8. Review exercise, page 8. This is how the examiner asks the question. Review exercise, page 8. Calculate the net present value for each project for discount rate of this. 1, 2, 3, 4. This is the question 5B. In fact, in the question 5A, it asks you to find the rate at 8% already. The one that we did in the class just now, alpha, omega, before the break. So in fact, you find 8%. Now the question in the question A, now the question B asks you to find on MDB for the two projects, 10, 12, 14, 16, 1, 2, 3, 4. That means in total you have to find 5 there. Use the 5 rate. Just now you have 8%. Now you got 4 more. So 5 rates. Use this 5 rate to plot to draw the MDB diagram. And from there, find out the approximate IRR. Is this one? 5 rates for 2 projects. That means you have to find 10. And with the graph, 6 months. Okay, very time consuming. Very time consuming. Alright, ultimately, approximately, your answer is this. But this answer is still not accurate. Okay, so the more accurate one is you have to go through the information method. Okay. Alright, so this one, you have it on your page 8 as well. So what we have to do is that we have the alpha, those. Previous question we tried 8%. Now we try 20%, which is one of the rate that given by the questions. And find the MDB. At 8% we have to find the positive one. Now we find the negative for alpha. For omega, just now 8% we have a positive. Now we use the 20% we get the negative. And all this plugged into the formula and have the MDB diagram, have the IRR. Okay, not very accurate answer. Alright, class. Here I'd like to share with you, this question is more important. Available on your page 9. Available on the page 9. Okay. Just want to try that alpha and omega case, mutually exclusive, both have the positive MDB, but we say that we choose omega because omega MDB is higher. 2, we can only choose 1. Remember, we did this before the breakup. Class, like to share with you these and other questions available on the page 10 of your review exercise. 9 of your review exercise now. Okay. Alright, let's go back to the alpha and omega. Alpha gives you 14%. Omega IRR is 12%. Which project should you choose? According to IRR, which project gives you a better return? Alpha. Okay? According to IRR, alpha says we should, according to IRR, we should choose alpha. But just now, before the break, according to NPV, we say that we should choose omega. Okay? So, in your page 9 of your review exercise, on the page 9 of your review exercise, okay, on the page 9 of your review exercise, what is the decision? According to NPV, we have selected omega. According to IRR, now we choose alpha because 40% is more than 12%. That's the omega. Okay? We will have this kind of problem, meaning that NPV and the IRR have inconsistent results. NPV say choose omega, IRR say choose alpha. They have inconsistent results. They have inconsistent recommendation. Which one should you follow? You should follow NPV or follow IRR? Follow NPV. So choose omega. Why you choose NPV? Why you follow NPV? Maximize share on the score. That's the standard solution. Okay? According to NPV, you choose omega. IRR selected alpha, have the different selections. This kind of problem will arise in a situation where we have mutually exclusive projects. The solution is follow NPV because it's consistent to maximize the share of the score. So the answer is still omega. Okay, important one now. Okay, one more homework for you to do. Zone A 21158. Homework. 21158. Okay. 21158. This one they normally ask in the A, find NPV, in the B, find IRR. This is a very standard thing. Okay? So traditionally, you see that the cash flow are very simple. Not like just on that question. Very simple cash flow. Only 3 years. Let's go and see your these 2013 question. The 2013 questions tends out to be this way. So far, we never see any of the questions we saw from PSC in your previous syllabus. In other syllabus, this is very common. This is a very common thing. Traditionally, your PF, NPV calculation is very simple. Here is the 6 years, 2 projects with the different project life, with the different investment. And the next cash flow are different. NPV out of the next 17.5. Okay, and what find the IRR, and what find the okay, so question A asks you to find this. So class, this is your Zone A question 6. Do the B as well, find the IRR. C as well, what should be your investment advice? Right. Okay. Question assess the usefulness of IRR, 6 months. Critically assess the usefulness of IRR. Okay? What does it mean critically assess? That means that you have to talk about the good and the bad. Okay? You have to talk about the good, the advantages and the disadvantages, both sides. Both sides. Okay? And talk about problems. MPV are considered the time value of money, and we consider many problems. Okay. Right, so all these are your assignments. So the question ABCD are up to the F. I put all down there for you all. And page 11, you have some further questions. 213. Okay. Right, have to finish all these counting questions. Right, clear? Right, this is the one for your MPV. The last one, very, very simple payback. Okay? Class, can I share with you a little bit more? In fact, traditionally, when you start your PF syllabus, when we test this capital budgeting, what we normally will ask is, okay, in the traditional capital budgeting, any of these methods, when we test the candidate, we normally will ask the candidate to know the advantages and the disadvantages of all the methods and the calculations. Okay? So in the revision time, I'll give you one additional summary, which is not for the subject. I'll give you a table, and the table will show the different advantages, disadvantages for your extra information. Okay? Alright, now let's go and see the very last part of the payback. We need just a few small page for this, for the payback. Normally, in many books, we discuss the package first, because this is the easiest one. Number 3, payback method. It gives you the number of years. Okay. We will take the payback of the project. And the company has a cut-off period. Let's say the company requires the project to be covered in 3 years. But we managed to calculate, the project managed to get money back within 2 years' time. We are going to accept the project. Okay. How to find a payback? Very simple. Okay, let's just say a simple situation. 2 years project, cash flow. Today we pay 150. From here we're going to pay $100. Let's say, in this case, are we able to get the money back in the year 1? No. Are we able to get the money back in the year 2? Yes. But we don't need 100. We still have another $50 more. Of 100. Okay? So the payback here is 1 plus 50 over 100. This is 1.5 years. That's all. Is that right? Okay? But this payback doesn't consider the time value of money, so ends up to have a problem of this. So payback advantage very simple. Very simple to calculate, very simple to understand, very useful. Why? Because it gives us the information about how many years and to consider the risk. We will normally choose those projects with the lower payback, meaning that we can get the money back earlier. So you have considered the risk. Okay, so that's why we normally say that this payback is a screening device. Before we go into details about the project, we will use the payback to screen through first. Should we consider further or not? If the payback says no, then we do consider further away. Advantages and the disadvantages. It doesn't consider the time value of money, UVM. It ignores the cash flow after the payback. We're going to see that later. Okay? How do you set the 3 years? If the manager say it's 1.5 years, we're going to reject this project already. Manager A can set 3 years. Manager B set at 1.5 years. Manager A will say accept, manager B will say reject. So that's why it's very subjective in terms of the cut-off period that we set. Okay? So never mind, this problem without ignore the time value of money, we still can improve this by counting another version of the payback, which is the discounted payback. Two versions are version 1, version 2. So the discounted payback, if you want to discount the cash flow to find their present value, let's say we discount it at 10%. Okay? So this is 0.9, 0.8, 90, 82. Now able to cover in the year 1, we still need another 60 out of the 82, which is about 0.873. So according to the discounted payback, we need 1 plus 6 over 82, which is 1.73 years. Which give you a more accurate answer. Payback or discounted payback? Discounted payback. It's an improved version of the payback. Okay. Alright, first, I'd like to remind you, normally, and these are the topic 7, investment appraisal. Topic. We don't just need to calculate. We need to calculate for the NPV, IRR, and the payback. Okay? A lot of times we need to discuss the advantages and the disadvantages of the method. Okay? And as I mentioned just now, so in all my capital budgeting questions, I normally test them this part as well. But in your subject guide, it doesn't give you a very clear idea. It does mention, but it doesn't give you very clear idea. So I'll give you a summary of this in future. We go to the question. And here, if the question say discuss, and like just now that one, critically discuss, your answer should be different. If you see the word critically discuss, you should have advantages and disadvantages. So don't forget one is critically discussed, we must discuss 2 topics. So we're still on